Good afternoon, everyone. This is Mark Durgenti with Burt Process Equipment. I want to thank you all for joining us today. Today we're going to be talking about custom systems. And before I get into that, I just want to kind of give you guys a couple of small announcements. During the presentation, we will have a poll question for those who wish to answer and engage in the talk. We will also have people monitoring questions. So if at any time during the broadcast you'd like to ask a question, please feel free to type it into the chat window, and we will try to address all questions during the presentation or afterwards. There will also be additional time for questions. Any questions that are not answered during the broadcast, we will answer in email afterwards. There will be a brief survey sent out as well. We always appreciate your feedback. We are planning our 2022 series at this point. So if anybody has any recommendations or topics that they'd like to pursue, we're always interested in hearing from our clients. So today we're going to be talking, and obviously this is the last webinar of the 2021 series, so we're kind of doing a little bit of a specialty topic today. We're going to talk about custom systems. And we're going to do something a little bit different for those of you who have traditionally followed a lot of our webinar series, in that, obviously custom systems is an extremely broad topic. So today we're going to focus a little bit less on going into the specifics of one type of system or the type of design that really goes into them. Instead, today we're going to really talk about really what the process is for developing a custom system. We're going to talk about a little bit about the capabilities and kind of why and how you can produce customized systems. And we're going to kind of go through a number of just kind of very simple case studies here, just kind of showing a lot of the different things that have been built over the years that people may not realize are actually made. And again, like I said, if anybody has any questions at any time, please feel free to jump in. And without further ado, so to understand a custom system, first understand the capabilities. So a lot of people who've worked in the industry, work obviously in construction, projects, and process. You have different vendors for different types of systems. You have pump suppliers, you have tank suppliers, you have different skid suppliers out there. And, by and large, a lot of people specialize in very specific things. They have certain type of pumps or instruments or panels. And, we at Burt Process, we obviously follow a very similar mold. There are a number of different systems out there that we build, which people have kind of come to know us for over the years, pH adjustment systems and high purity water, lift stations. But really what goes on behind that and what separates, certain vendors, and certain manufacturers from others is you're not necessarily building a widget. You're not saying, okay, I have a product catalog and I have items X, Y, and Z in here, and this is what we build. Those standard products are really the culmination of design and development and years of experience that are kind of backed up a lot by, having mechanical and process design experience behind them. And when you get into the realm of custom systems, it's really taking that knowledge base and then expanding it into making something that may be similar to something that that you build as a standard. It may be customizing a standard product, or it could be something entirely different that really just draws upon the resources, the technology, the equipment that the company represents, to really tailor it to meet a client's needs. So a little bit of background, as I just said before, about Burt Process. In general, we as a company are known in the industry, for our water treatment systems. But, behind that, we have a very large fabrication group. We have a facility here in Connecticut. It's almost 100,000 square feet. We have a segregated stainless steel, and steel fabrication. We are UL 508A panel shop. We also build hazardous duty control panels. I myself am a chemical engineer. We have a full mechanical, electrical, project managers, designers on staff. And while we work in those standard products, obviously a lot of that unique capability, we're also a master distributor. Some people also don't realize is that we have distribution arms on both the East Coast, the West Coast, and the central part of the country, where we represent a lot of different instruments, pumps, in other types of devices, which are commonly implemented into our systems. What this kind of gives us is really a sort of a horizontal application where we can draw on any number of different facets of the company to allow us to, one, obviously make the standard products you guys are all familiar with, but also allow us to kind of go into the realm of more custom systems. And a lot of custom systems often start as a modification of a standard product. And in this case here, obviously the thing we're probably most known for in the industry is pH neutralization systems and wastewater treatments, whether that be for pharmaceutical, semiconductor, higher education, general industry, same thing with high purity water, rainwater, obviously our control panels, obviously support that. Chemical feed, if you're looking more in the municipal markets or even for, more food and beverage type clients, and then obviously pump lift stations in support of those different technologies. A lot of custom systems start with the idea of, hey, I need a certain kind of pump lift station, or I need a pH neutralization system, what really kind of separates is whether you have the ability to kind of take that and go through that design process, from that sort of napkin sketch idea of, hey, I need this type of system, and then really move it into what could be, I like to use the term kind of customizable standard, in the sense where, hey, I take a standard product and all I do is place it into something different, or bring it out of a different material to make something wholly different in that sense. And a lot of that is really drawn out of the different capabilities. For those of you who are unfamiliar, a lot of these different things are actually built from scratch. You can just see kind of a quick picture here. Things like tanks, skid assemblies, the piping runs. A lot of that's all, even in the standard system where they have standard drawings, it's all being fabricated. It's not an assembly line type process. You do have that ability to heavily modify the systems as necessary in those cases. You can change the tank diameter from, say, 8 feet to 7.5 feet to 7 feet, 8.5 inches. And that's the kind of thing, where you kind of really begin that sort of customization process. And that can be applied to really any facet within the fabrication of the system, whether that's the thermoplastic, the piping, the controls, different selections of instrumentation, and even bringing different materials at that point as well, whether it be fiberglass or stainless steel. And a lot of that real design work really starts, at the engineering level. And, excuse me, as I mentioned, really what we get into when we talk about custom, really any system that we get involved with, one of the things that we really do is focus on that, napkin sketch approach, where you can, I have an idea or I have a system, right? I need a mixing tank. And then it kind of balloons into something much, much greater. And that really comes from both the process side and the chemical engineers like myself, to the mechanicals, to the electrical, at the kind of the design development level, and then really kind of transitions through that, into the mechanical design, into the sort of submittal back and forth at that point, and then finally into more of the custom programs that go into those as well. Obviously, you're not going to, for custom systems, you need a wholly custom program. As you can see here, this is just one example. It's a 3D image. This is actually a copper sulfite reaction-based system with these different crystallization towers. This is the kind of thing you can take a very simple concept, such as, I need a reaction tank. Now you have an insulated tank, or it's a pressure vessel, and you have all this different technology and heat exchangers coming together to make essentially a custom process in those cases. So I like to say, if a client can dream it, somebody can probably build it. And there's a lot of different reasons that could drive somebody from, more of a standard system into going into more of a custom system. And obviously, if you can make it work, standard systems certainly have their benefits. If I have a pH application, for example, and I need the ability to, and I need 50 GPM, I'm going to throw in a 50 GPM standard system if I can make it fit. obviously constrained footprints, unique process. I have solids in the waste. I have high temperature waste. I have a proprietary chemical involved in the system. I need to put the system outside. These are the kind of things where you really start to kind of tumble into that realm of more custom-based systems. And that's kind of the difference between, more of a process, kind of development house and more of basically like a skid builder. There are people out there, and that's what they really do. And that's certainly good in certain applications where you have someone who says, give me a set of prints, and I'll just build your prints exactly. That's really just skid building at that point. They're going to buy out certain components. They're going to have very specific bill of materials supplied by the client, and they're just going to basically fabricate it at that point. While in the end, this is a very similar process. The real difference is that kind of hand-in-hand exchange of ideas and engineering that go between the client, the engineering firm, and then the actual system manufacturer to bring that kind of custom idea into reality.
So, Mark, I had a question for you relating to the design approach on this. And for those of you who have not heard my voice before, I'm Maddie Mulqueen, and I'm one of our sales engineers here at Burt Process Equipment. And I helped co-host the last webinar, so I'm helping Mark out this time. So a question I had was, you were talking about sometimes you're customizing an already standardized product and essentially adding some modifications to it. And sometimes you're going directly from a napkin sketch. So what is the design approach when you are, doing a customized system? What does that look like for our engineers in-house when they are going from the initial design to fabrication?
That's a great question, Madison, because that's one of the things that people maybe kind of shy away from when you think about the idea of a custom system is, okay, I have an idea in my head, and how do I take this from a concept all the way into something that can actually utilize in my system? And, you have to understand that obviously, adding customization adds time, to the overall project. It doesn't necessarily add cost. It can in some cases, it doesn't necessarily add cost. And, really that starts with that kind of initial conversation. You have a need. I have a need for a specific kind of, say pump system or wastewater treatment system, and I have an area footprint. And really from there, it's having that open conversation, it's asking the right questions. And then, even at the very early stages, it's kind of sitting down and saying, okay, this is what we think the idea will be, and then having that kind of back and forth exchange with the client. This is what we want to do, this is what we can do, and then from there kind of building sort of a joint solution and saying, okay, we can use this as a basis if it's possible, standard design, and we can add these different options to it. And that's really just drawing on experience at that point, and bringing that to the client. And really, even from there, you generate a proposal, but even at that phase, you're really not quite finished with it. There's going to be, because, there's always the famous cartoon where the person wants a swing, and the sales engineer thinks he wants a wooden plank with 2 ropes. And then, the initial design engineer thinks, well, it's really going to have 2 or 3 planks and 2 ropes. And in the end, the client really wanted a tire with a rope swinging around the tree. And that's where you have to kind of sit there, even as the client, like, okay, you're not really done at that point. Here's your submittal documentation, or here's your preliminary submittal documentation. Here's a P&ID and a major, and an instrument list. And like, okay, this P&ID, I need to change a sensor here. I need to move this here. Okay, resubmit that. And then, once you have the agreed upon process, then you move into the mechanical design, the electrical design, the footprint, and then it always kind of has that kind of open back and forth going on. And that's really kind of essential, to ensuring that in the end, what you dream is actually what you end up getting, and you don't end up with something that's in the sort of vein of what you wanted, but obviously is not. But that obviously does add a bit of cycle time. And sometimes for some of these kind of applications, not necessarily the build time in that case, but a lot of times the design time and even that sort of initial, approach with the client during even, before something's even quoted or drawn up, that cycle time can take a couple of months, or even a year, depending on the scope and the size of the project. So at this time, we're going. Oh, thanks, Madison. So at this time, we're going to have our poll question if you guys are interested, and then we'll kind of discuss it after that. All right, we'll close the poll now. And so the poll question obviously is not a technical one, but what I was really interested in knowing, because it's kind of an interesting feedback question, as you talk to, engineers and clients and, people in construction and end users is, would you rather modify your own process, for the expediency of looking at a standard system, or would you rather look at the idea of, hey, I really kind of want us to do this, and, can I actually invest that time and resources into, going more into kind of a customized system at that point? And a lot of times it's kind of interesting because sometimes a customized system in the end actually becomes something that more people actually want. And, a lot of the different products that people do fabricate, on more of a mass scale after that, do tend to actually, kind of derive from this sort of initial idea of making a custom or more of like a one-off system. And what I tend to find is kind of split down the middle, but even in the end, almost every standard system does in some ways end up being customized. So kind of transitioning here a little bit, I mean, what is a customized system? And customized systems, again, customized systems can be something, taking an existing concept and just putting it, into a different type of design, or building something really wholly unique. And this is kind of an example here of just, this is basically a standard pH neutralization system, but it's built into an entire environmental enclosure, as opposed to being, located on a skid and inside. And containerization, which is obviously coming a lot in sort of modular design, it really is customizing a standard system. It's moving away from the idea of having, a skidded system in a mechanical space where you kind of fit everything in. And it's really going into, hey, we put these different utilities outside. It becomes customized in the sense that you're incorporating other design features and you're working within a different kind of a footprint, something that can actually be shipped and pre-tested up front, may even have its own systems like a chemical safety shower integral to it. But in the end, this is really customizing, an overall standard concept. Whereas there are some examples which are wholly unique. And in this case here, you have a fully containerized hydrofracking disinfection container. And this is taking customization to a different level where you have chemical feeds type equipment that's built into a fully mobile type unit. This is something that's actually a DOT rated. Everything has to be designed for DOT rated at that point. There's actually office space located in a system like this where the operator can work. And this just kind of shows how you can take something like a chem feed system and it can be implemented in something that's obviously a much more, robust concept. And this isn't as common. Obviously, hydrofracking itself is not as common as it was several years ago. But the idea of mobility in systems, is certainly there, although it does present a lot of its own challenges. We have a couple of pictures later on in the presentation which shows a number of different kind of custom lift stations that are on carts. And one of the issues of anything that's mobile is really going to be not just obviously if it's, whether it's the DOT or if something that's going to be pushed around your facility, is, thinking about things like venting on it. If you have specialized venting, you need to have that ability to vent it wherever you end up moving the system at different points. You need to be able to have the right power to it, which is not going to be a hard powered connection. So these are the kind of things that kind of also on the design end, when you move into the realm of custom systems, you end up looking at in those cases. All sorts of different, lift stations, hazardous duty lift stations in these cases, for different types of systems here. Everybody's familiar with kind of a standard lift station or standard solvent design. These are explosion proof. They have fire suppression systems in them. They have self-closing doors, different safety features, different configurations and pump technologies. And even really different sizes even, something like this guy here, if you can see my mouse moving, this is the size of a microwave. So it's basically building an entire system that's designed to fit into, a very specific footprint. Footprint a lot of times is also a governing factor in making things very customized in those cases.
Mark, so I had another question for you. So based on those two slides alone, right, those systems look very, very involved. So I had another question on what does the extra time look like to go into designing these systems? Is it, weeks? Could it be a month in terms of engineering and the communication needed to go back and forth between the engineer, designer, and the customer?
It certainly can be, and that's one of the things obviously to recognize is that's probably your biggest impact going custom is not necessarily costs inherently. It's going to be time. It's because it's the idea of obviously taking a system like we're showing here and coming up with that from what could essentially be almost nothing as a basis. It's really just, hey, I have a utility requirement to pump out a specific chemical in a hazardous location, to a full-blown design that obviously does add, obviously several, does obviously add weeks into the overall design process at that point. So that's something, to obviously look at. Can it be months? It can. A lot of times, what will happen is it's, in the project planning phase where you have an engineer or a client, who's doing something, I'm thinking about a project for next year, kind of reach out, sort of start that very high level design. That's oftentimes these kinds of systems sort of start is, I have an application and I want to kind of move into it. And that can be kind of an on and off conversation, at least getting you to sort of a basic concept, over the course of a few months before you really get into that more detailed design at that point. Thank you. And this is kind of a good example of that, looking at more than like a custom pH system. Obviously, anybody who follows the webinar series talk a lot about pH systems. And then you have something like this where you end up with a pH system here, which is located outside. It's explosion proof. It's treating strong waste. It's completely insulated, and heat traced. It has special venting requirements. This is how you can take a fairly simple system and make it very complicated in a lot of those different cases here. I mentioned containerization because I think it's coming a lot bigger, I'd say, in the past few years. And even the idea of containerization itself can also be very customizable, where you can have things as simple as basic shipping containers to things almost like modular buildings in these cases. And in this kind of case, because of the idea of having to make this into modular buildings, you actually have to split the system into two. And that's also becoming a lot more common, where you can end up with actually multiple different utility areas, where you'll have a system like this. And then it really going into the design of what goes into that, certainly takes a lot of effort in those cases, to have the access you need, to have the ability to pull these things out, the different roof configurations in there. That's a lot of stuff that also kind of goes into, you look at the idea of containerizing in different systems. But sometimes customization is not something that's so grand. And sometimes the idea of customization comes from the idea that I can take a system that's fairly common and just use it in a slightly different application. And then what will be involved in taking that, from kind of a standard design and then utilizing it in that application. And that's really what you have here. Where, obviously a lot of people make a lot of different process lift stations. And more or less you see them for things like wastes or solvents. But in this case, it's taking that concept and bringing it into the CGMP area of pharmaceuticals, where you have a chemical that will be will be pumping as a lift station or chemical feeds type device, into that CGMP area, and it's taking that kind of standard design now and making it, USP class 6, making it FDA approved materials, making it all sanitary at this point. That's another form of kind of customization, where you take a certain application, you take a certain system, and you modify it for use in a more specialty application. And that's really what you have here. And this is actually a fairly common thing. People will take this and be like, okay, in this case, we're talking about pharmaceutical grade. It comes up a lot in semiconductors as well. As I mentioned, I just showed you a bunch of the solvent style systems where they're going to be explosion proof. But this is just an example here where you can take something that's fairly common, and using it. There's hundreds of these across the country, and modify it into something that's actually utilized in a different application. And then you end up with essentially wholly different types of systems. And this is really where you take the idea of that mechanical and process design and you move it into building systems that are either less common or highly customizable. And that's really the case here. It comes up from time to time, things like heat exchanger skids or PCW, which is a process chilled water system in those cases. And that's really taking in the mechanical and electrical, as well as the resources you have at your disposal to do, stainless steel fabrication, to do that process design, that pressure design, the expertise you have from your experience in high purity water systems and pH systems, or cooling and heating the various solutions, bringing that heat exchanger expertise into it, and then building kind of a wholly new type of system, which again is not very common. Those of you unfamiliar with PCW systems, they're used a lot of times in industry, and specifically semiconductor or medical device manufacturing, where you're trying to do basically control loop, outside of like a chiller-based system at that point, where you're basically doing a process chill water loop. Kind of like the idea of a roadie system, but they obviously, a little bit different in those cases where you have kind of recirculating a loop, but you're basically doing temperature control throughout the building. And these type of systems can utilize a lot of different technology. That's one example just shown here. They can also have chemical injection, because obviously now you have a recirculating system, kind of like a radiator-based design. And really what you're looking at here is just making sure that what you're bringing here is that technical and process expertise to bring that, to really treat that kind of waste, to really design a system like this. Same thing with this application, where you have, where you're taking something that you do for commonly like a pump treatment system, and you're applying it to a different type of technology. Here, in this case, you have Glycol system, and Glycol, for use in more of a chill water design, runs at a very low temperature. So this is taking a custom design, obviously, here for a building application, and you're going to be using low temperature pumps. So you're going to be using pumps that's going to be down in the 30-degree range, which is simply outside of the realm of what you'd see for most sort of water applications. So as opposed to looking at water or wastewater, high purity water, it's taking that technology and now applying it to a different type of chemical solution, in this case here, a glycol-based solution. And it's different pump technologies involved, you have different type of seals involved, and then obviously the custom design of the tank, the insulation designed into that. Those are the type of features that come in these type of systems when you're trying to customize the design. Just looking at a few more examples here, resin or filtration-based equipment. Again, something that is commonly built, but this is taking it to resins for things like iron removal. In this case, it's going to be a hydrofracking-based system. Then there's a lot of chemical processing that also goes involved with systems like this. It's understanding what type of chemical process, what kind of constituents you're trying to remove with the system. There's the mechanical design based on the flow rate for these types of systems, and you can kind of see here, this system was also going to go outside. And most people think of resin, they think of things like either metals removal or high purity water, and this is now applying it to more of an oil and gas based type system. So it's taking existing technology and kind of moving into that realm. But you can see you've got from everything from pump skids to sanitary, lift stations to glycol treatment to heat exchangers to now resin-based systems. And really, none of these fall in the realm of a standard product, but they're utilizing a lot of the same standard mechanical and engineering design that goes into the standard products that help kind of design these types of systems. And that's really kind of the difference. And that's why when people say, I might say, can you build it? The idea is you probably can, or I can tell you it's probably just not going to work. And that's one of the things that also comes up quite a bit with these types of systems is sometimes there is just a concept, and it's not going to feasibly be done that way, and then it has to be done a completely different way. And that's something that we can also bring, which is kind of bringing that experience to you and really explain to you if that really makes sense in the concept of what you're trying to do, or if there's just simply a better way to do that. In addition, a lot of times, looking at this is just one other example here. This is looking at a system which is, in the realm of things that obviously people are familiar with, reclaim or rainwater reclamation systems. And this is making it a lot bigger. Sometimes in the concept of customization is taking that flow, from the standard range people think of when they think of things like 100 GPM or 50 GPM reclaiming, going to something like 500 or 1,000 GPM. And it's upsizing that. It's looking at the differences between what more of a standard or smaller base system is to what it begins to look at, more of a larger application. And even looking at it a little bit differently, one of these systems here is actually utilized for a racetrack as opposed to being utilized for just something like flushing fixtures. So what they're doing there is they're basically spraying down a racetrack for training, collecting all that water, and then basically bringing it back. So it's in a very similar vein to what you'd think of for a rainwater or reclamation system, but ultimately, you're using a similar technology, but also taking into account the differences of now at the groundwater. The ground level. I have different solids constituents in the system. So I have a basic concept of, filtration, disinfection, and now it's looking at the different solids loading, the different filter technologies that go into that type of system, and then also the much higher flow rate involved in doing that. And then sometimes you just make wholly different proprietary processes. And that's something that also, comes up. That's something that also really drives custom systems is a client says, listen, I need something that I have an application and I need a system that can basically work within my proprietary structure. It doesn't fall into a utility for a building or a treatment system or a lift station. That's where you get into things like I need, a wet bench to do my actual wafer processing or do my actual battery processing, or I have this application like you see here on the right. They're doing like oil, basically oil pressure testing in the aircraft industry. And that's really just making a system that's designed for a proprietary application. And these are arguably the most intense form of custom system because you have a client that either has done R&D in that case, and they have an idea of like, this is the pressures I need, this is the flow rates I need, or this is what I'm trying to do. And you're really building something wholly from scratch that they're going to actually utilize within their process. It doesn't fall into really any kind of a standard design. And that can be thermoplastic, and that can be stainless steel, and that can really take almost any shape or size. And, this is really where it becomes almost more like a partnership in that case, whereby, you're working with a client and, you're under NDA, and there's a lot of back and forth, and then there's a lot of testing, but when it actually works, it becomes a part of their actual, profit at that point. It's not something that's just supporting them, something that's integrally being used, within their actual application. I think this is really the time where customization obviously is the most critical, because the system has to work exactly the way that they want it to work. And it goes through a lot of different design iterations to do that. And, and as Madison had asked me earlier, that's one of the things that really does drive quite a bit of time in those cases. And this was only one part of several other ones. You can see there you have a chiller on one side of it. You're bringing in other resources that even as a manufacturer you don't build, but you have an expertise in, and you're tying it into that system to make it more of a turnkey package for them. So this is where you really get more into custom, more proprietary based equipment. And again, these can be metallic, these can be plastic, these can come in a lot of different shapes and sizes. And I could literally show you many pictures of systems like this, but just kind of give you guys an overall idea, that things like this can be built. And a lot of times these are engineered, inside the client themselves, by their engineering group, or they may have a prototype in mind, and then because really scaling up that prototype or that design concept, or in some cases replicating a system that's, hey, I use a system at my plant overseas, and I need to make it here in the U.S. now. That's where you really get into these much more custom type systems.
Mark, so going off of all that you just spoke about with that, when you have layers of approvals and you have external engineering and you're working with another company's design team to make something come to life that they would like designed, what qualifies the manufacturer then to design and fabricate that system?
Well, that's actually a really good question, because one of the things that does come up is, you know, when somebody has when somebody has a need, I need to build a custom wet bench, or I need to build my oil pressure test system. People are going to go online and they may start searching around. And if it's a system that nobody builds and nobody's going to build as a standard product, you as a client need to kind of look at, kind of who you find or who who builds equipment, and really do that evaluation of, does this person have the engineering knowledge? Do they have the process-based knowledge? Do they have the fabrication capabilities? Or are they more of just a skid builder? Do they have access to the right pumps, the right valves? Do they have the right in-house programmers to talk the language or use the components that I want to use in the system? And that takes a little bit of investigating out in the client's part, meeting with different vendors, meeting with, their salespeople, or even, and sometimes you'll find them at the most unusual places, different trade shows, for example, or they may come in and be like, I had this client come in to talk about a pump. It turns out I had no idea that they can build all this other stuff. And that's where I encourage people to, set up a conference call, set up a webinar with someone, and really kind of go through that, and obviously, outside of the current conditions, the best way to really investigate that is a site visit. If you can go to the client's facility, you can see their fabrication and meet their engineering team. I think that'll give somebody a lot of the confidence to see that they have that ability to really build and partner with you to make that system work the way you want it to. And I think that's one of the key things people need to realize, at least with a client. It's not going to be as simple as just going online and just kind of searching the web to see who can do this. You're going to find somebody, they're going to have something in the vein of what you want, or they have maybe the capabilities, but really what you want to look for, at least for this type of custom equipment, it's going to be that, process expertise, that mechanical expertise, that real in-house manufacturing, that ability to pull in other resources or other types of vendors to support that system, whether it be fiberglass tanks or chillers or heat exchangers or compressors, then have that project management and programming, and then also, most importantly, startup services to actually support that. When the system, when this gets into the field, particularly the bigger ones, it's really critical to have that testing, that, the SAT testing, and even in the factory, the FAT testing to prove the system actually works properly. Kind of rounding off here a little bit as we get towards the end, sometimes, custom systems just kind of fall in places you wouldn't really expect them to. And, this is just one example here of a chemical safety shower system. People don't realize that even the things you don't see, normally, or maybe even just see in the movies, hey, the person walks out in the blue moon suit and gets sprayed down. There are systems that actually support that. And, that's when these systems, obviously something like this here, is not something that's necessarily a standard product. There's not a lot of, say, BSL-3 or BSL-4 labs, in the world. These are basically built to the facility's needs. And obviously in that kind of a case where you're talking about biosafety level, there's very specific and tight control requirements that also go into these types of systems. So again, that also, just even that level of programming sophistication or controls, or understanding the chemicals being utilized, that also kind of falls in the realm of customization when it comes to different systems. We focus a lot today on kind of some of the bigger ones, kind of maybe having a little more of that wow factor, but honestly, custom systems can come in a lot of different sizes, and they can be relatively simple. Something that can be as simple as a test system where you have just a very high-end piece of flow technology, basic filter systems, very simple heat exchanger designs, different chemical storage, applications. It really can run the gambit. And these types of things obviously are more napkin sketch based. Like I have a system and I need just a filter for it. I need to control temperature in there. And here you go. You can build a much smaller or simpler custom design. And it's worth noting, as an engineer or as an end user or client out there, thinking about this, if you do have applications, it never really hurts to ask, hey, can somebody actually build something like this? And, while, you can talk about it at least get an idea of, what's feasible out there. And a lot of times, that's kind of where it starts, is what is the actual feasibility of doing what I'm trying to actually do here? So that's kind of really kind of the takeaway about custom systems is there's really a few things to kind of bear in mind. I mean, one, standard systems certainly are beneficial, and they are the most economical from a time standpoint and a resource standpoint. When they're not practical, a customizable standard can also be utilized. And when that's not the case, custom technology and custom builds are out there, and they can fit either, customizing, something that as a vendor somebody makes, or customizing something to really fit your proprietary technology or utilize it in a different way. There's a lot of different options out there for building and designing custom systems. I want to thank everyone for joining us today for our final fluid series of 2021. We'll be on here for a couple minutes for any more additional questions, and also we will be posting here in the next, probably the next month or so by January what the 2022 series will be. Obviously today we're talking about a little bit of a different concept, so if anybody has any applications they want to talk about or something they just kind of have an idea about, certainly feel free to reach out. We can certainly talk about it, at least discuss the feasibility. And again, we're always interested in your feedback. If anybody has any webinars or topics they'd like to talk about, going into next year, you can definitely let us know. We definitely do take that into consideration. So with that, I wish everybody, I say thank you, and we'll hang out for a few more questions. Now, we have one question here, which is, can I describe what I mean by customizable standard? So when I say the term customizable standard, that's not really an official terminology. That's kind of more of something that kind of used a little bit more in conversation. Is a customizable standard is taking something that's a standard product. Say it's a certain pH system. Say it's one of our standard pHXs or ACSs, and it's changing it in a fairly small way. Your system is 8 by 12 by 8, but I need it to fit into an area that's only 7 feet wide. So now it's going to be 6 by 15 by 8 feet tall. Those are the kind of things I say are more customizable standards. Yes, they do take a fair amount of design input still, because obviously you're taking something, now you're changing it, that changes the tank size, that changes the mixer sizing, from the shaft length, things like that. But you're not creating, that's not truly customizing. There's kind of a blurry line where you have the idea of customization, where is it kind of a standard as a basis to now you're sort of in the realm of being very, to being truly custom at that point. And the line is kind of not really relevant, obviously, because really in the end, what you're trying to do is build what will actually work, or design what will actually work for your client. So, if it's a concept and something that somebody makes, fits into that mold to start with, that's a really good place to obviously begin the design process. But you may find as you go through the design process that you need to do something wholly different, or the application is just not going to be a good fit for that. So customizable standard is just more of a nomenclature term to say, hey, if I have something that does fit but it's not perfect, there may be a way to modify it slightly in those cases. We have one more question here. In talking about containerized systems, how's containerization, or what's kind of the differences between containerizing a system and putting it in more of an outside-like location? So both of those options are feasible, where you have a container versus an outside. So certain systems can very easily be built to be put outside and be environmentally, controlled that way. Large storage tanks are. Different types of pump systems are designed for that. A lot of times when you're talking about more high purity water, you're talking about things like wastewater, they're built to be more corrosion resistant in those cases. So, heat tracing them and weatherproofing them and UV proofing them isn't always a very feasible alternative. That's where the idea of containerization came up. And it's really been expanded quite a bit with other types of systems where you basically can have almost like modular buildings that are built on site. And, one of the benefits of that is you have the ability to basically build the whole system, lighting, everything else, test it, and literally just drop it on site with the idea that you can then just hook up power and utilities to it at that point. All right, one more question here. if I had to make the choice between a custom and a standard system, which one would I choose? Well, you guys are going to flip the poll question back on me. As an engineer, I would say that I would go with a customized system if I could, which again, but, obviously practicality-wise, if the shoe can be made to fit, it's also, there's pros and cons to both, obviously. And, in the realm of, sales and things like that, people like to push standards. People like to hear standards. Here's a catalog. I can see it online. I can plug it into my drawing. But obviously, the further you get into the weeds and the more experience you have with these types of systems, things do change, and it's good to know at least that you can actually go down that road, as needed, to really design a system that actually works for exactly what you're trying to do. And I've worked on probably hundreds, almost not 1,000 projects, and more than not, they're going to go custom in some way or another. I'd probably say 75% of them go custom in some way, and probably half of them can go fairly custom at that point. So as much as a good basis to start, I am seeing, definitely a push towards that more and more to try to be a standard, even if there's flexibility and options. But sometimes, obviously, going down the realm of custom is what you have to do in those cases. All right, everyone. Thank you very much for joining us. And again, feel free to email us with any additional questions. Again, thank you very much. And everybody have a good holiday season.